Okay, now we talked about what a difference of perfect squares is, okay? Now you need to identify the expressions that represent a difference of perfect squares. Some of them are, some of them aren't. Now the first thing you check for is a negative sign or a minus sign. You got to have that sign right there. You can't have a plus. So x second we know is x times x times itself. And then here's 9, that's 3 times itself. So write yes. Okay, that's a difference of perfect squares. Okay, now, I don't look at these until I know that that's a negative. It's not, it's a plus. So right away you write no. You don't even look at the chart, okay? You don't mess around. It's got to be, this has to be a negative sign here. Again, did I mention this had to be a negative sign? I did, and if it's not, it's a no. It's not a difference of perfect squares. Okay, now we have a negative sign, and x to the second is x times x, but as I look down this row, I see no 14, okay? So I can't write 14 as anything times itself, so that's going to be a no. Okay. Next one, you have the negative sign in there, so once you have the negative sign, you look at this and you look at this. So here's 16, that's 4 times itself, so 4 times 4. Now attached to our 16 is x to the second, and that's xx, so what you need to do is you need to attach an x to each factor of 4. Then after the negative sign or the minus sign, you go take 25. 25 is 5 times 5. So that's yes, I made it all the way through. I had the negative and I wrote 16x second as 4x times 4x, and then 25 is 5 times 5. So that's a yes. Okay, 4x to the second power minus 81. So this right there, that symbol I'm looking for is there. And then 4 is 2 times 2. Now attached to the 4 is an x to the second, which we know is x times x. Now, so this has been written as something times itself, 2x times 2x, 81 is 9 times 9. So we made it all the way to the end. We have the negative, and that can be rewritten as a factor times itself, and so can that one. So that is a yes. Okay, 3x to the second minus 49. Now we have a minus. Now let's look at the number 3. 3 is not a perfect square. Okay, there's no number times itself that gives you 3. Okay, so you write no. If you're not able to rewrite that as something times itself, it's no. It's not a difference of perfect squares. Okay, got the negative. 49 is 7, 7. And then we know attached to the 49 is x second, so I look to attach something times itself on that 7s, that would be x to the second. So it's x, x. And after the negative, you have 64. 8, 8. So I made it all the way to the end, so that is a yes. Okay, x to the second power minus 144. So we have the sign that we need. X second is x times x. Then I go down, and here's 144. That's 12 and 12. Okay. So yes, you make it, if you have the negative, if they're separated by a minus or negative. Now plus, don't circle the plus. If it's a plus, that's a no right away. Okay. Now here we're back to having that, so 16, that'd be 4 times 4. And then x to the second is x times x. You put x, x. Now after the negative, you have a 1. Well, 1's here, it's 1 times 1. Okay, so that's a yes. Okay, we have the minus sign. But 7 is not here, so that is a no. Okay, we cannot write 7x to the second as anything times itself. 25x to the second plus 4. If you have a plus sign, it's a no right away. Okay, it doesn't matter what's on the side. Difference of perfect squares only works if this right here is a negative. Okay, now we do have our negative, and 4 is 2 times 2. X to the second power, we know that's x times x. Then 81, 9, 9. So that is a yes. Okay, when I say to do plus sign, if it's a plus sign, you write no right away. Another positive sign, plus sign, whatever you want to call it, it's a no. Okay? And then on your assignment, you go find the ones that are difference of perfect squares.